Invitation, and also appreciate all the people that have tuned in today. It's a little sitting here in my studio at the house doing a webinar, but we'll see how it works out. As Molly mentioned, I'm going to be talking about several aspects of southern pine beetle today. My main focus on my day job is southern pine beetle prevention, but I've been working on southern pine beetle for the past 15 years, or 17 years actually. So we'll go through kind of the basics and then talk about the SPB prevention program. For some reason, there we go. There we go. Got the slide to advance. I'm going to be talking about southern pine beetle, which is a native pest to the southern United States. It is the most aggressive and destructive of our southern pine bark beetles, which there are several. But SPB, southern pine beetle, is the one that people, I think, know the most and have had the most experience with in the past. Outbreaks of this insect generally occur about every 7 to 10 years, and those outbreaks generally last about 2 to 3 years when they happen. And so we think of this insect as a cyclical insect. Sometimes it's nowhere to be found, and other times it's blowing up and wreaking havoc, causing all kinds of problems. And we call that an eruptive type pest. And I'll talk more about that here in a minute. In the southern states, it can attack all of our southern yellow pines and even eastern white pine, but its preferred host are loblolly and shortleaf pine. And it attacks trees in what we call spots. So you'll have a small group of trees, 2 to 3 trees, or even 1 tree, and that infestation will grow out in what we consider to be a spot. So throughout the presentation today, you'll hear me reference spot, and that's kind of what I'm talking about, that growth of the infestation. And I'll show a picture of that here in a minute. And in order for that spot to be initiated and for that spot to grow, the insect, the southern pine beetle, has a very well-developed pheromone communication system. And I'm not going to get too deep into all of the components of the pheromone communication system today, but just know that it's very well developed in this insect, and it's how spots grow. And it's also an opportunity for us as forest managers to disrupt that pheromone communication and disrupt the spot. And I'll talk more about how we would do that later through the presentation. So I think a lot of people think of southern pine beetle, obviously, as an insect that's associated with the southern United States. But as you see from this range map, it is clearly all across the southern United States, but it's also found in New Mexico and parts of Arizona, through Mexico, and down into Central America. And actually, over the past decade, there's been quite a bit of activity of southern pine beetle in Central America that's caused quite a bit of issue. But the focus of my presentation today will be in the southern United States. There also, in the past decade, has been activity up in New Jersey and even out here on Long Island, which on this range map from 2009 is not lit up. But if you have been to Long Island recently, out near the Hamptons, this insect has been causing quite a bit of damage in pitch pine out on the island, and has recently even been caught in Massachusetts and Connecticut, north of Long Island there. So maybe some range expansion, or maybe just kind of a weird event. But certainly a huge range, but most of what I'm going to be talking about today is just from the southern United States. This insect, as I mentioned, is a native pest to the southern U.S. And as far back as kind of our history goes here in the U.S., there are descriptions that can be found in the literature talking about infestations of this insect. And Steve Clark, Fred Stephen, and John Riggins wrote a paper that was published in 2016 that kind of describes these earlier outbreaks and how that relates to forest management over time. So that's kind of an interesting read if you're interested. But I'll also point out that one early report from the late 1880s by A.D. Hopkins, who we consider to be the father of forest entomology in the United States, described an outbreak in this beetle in the late 1880s that was in West Virginia and Pennsylvania and some other areas, part of which were in high elevation red spruce. So although it is weird for this insect to get into red spruce, it does periodically do that. And it did so in the late 1800s and more recently in the 2000s, early 2000s. Since 1960, we in the Southern Forest Health community have done a more concerted effort to try to record outbreaks and have a better handle on this insect. And as you see here, this graph goes from 1960 over on the left-hand side all the way through 2019. And on the left, the y-axis over here is outbreak county, and we define outbreak as one spot per 1,000 acres of host type in that county. And you see that this insect is indeed cyclical. So you have sometimes when you have low population levels, and other times here, like in 1975, 1974, 75, huge outbreak. Clearly a multi-state, multi-year outbreak that no doubt wreaked quite a bit of havoc on the landscape. And we dealt with this insect through the 80s, the 90s, early 2000s. Since 2002, there has been some change in the outbreak status of this insect for whatever reason. And maybe I'll talk a little bit about that later, just kind of throw out some hypotheses for you to consider later on about what you think may be happening, why the peaks are different here all through the 60s, 70s, 90s, and just look at the 2000s, very different situation. This is the same data. The blue lines here represent the same data I just presented. The red line, however, is economic impact. And you see, like in the early 2000s, this insect caused about $1 billion worth of damage in over a 4-year period. So when populations get very high, it can create quite a bit of economic impact and also ecological impact. And if you look at the data over time, not every year, some years it's zero impact, $0 impact, and some years it's a lot more than that. But the average is about $50 or $60 million a year impact on an average. And so since I'm a forest entomologist, I have to show the obligatory life cycle slide here. Goes from the egg to the larva, the pupa to the adult. And the reason I show this is because it's important to note that you can go from very small levels of infestation to high levels of infestation very quickly, because this insect can go from the egg stage to the adult stage in about 30 days, 30 to 35 days. And that's important from a management aspect. Also note that depending on the climatic conditions of where you are, you can have 3 to 5 generations, maybe even up to 7 in the southern part of its range. So you can go, like I said, from a few spots to hundreds or 1,000 spots in just one season or over two field seasons kind of thing. It's certainly something to pay attention to if you have a few spots and jump on it early. And I'll talk more about why that's important here in a minute. There are several other southern pine bark beetles that we deal with in the South, mostly the engraver beetles, which are up on the top right-hand side here. And these can be found with southern pine beetle in southern pine beetle infested trees, or they can be found attacking trees without southern pine beetle. And they can cause their own damage as well. They're not, I don't think, as important on a landscape as southern pine beetle when southern pine beetle really is rolling. But it's important to know if you have Ips beetles, engraver beetles, or southern pine beetle, because the management considerations are different. And I'm not going to talk much about Ips beetles today, but just important to note that you should know what in fact is killing your trees if you see trees like the one over here on the right hand side of the screen, because the management considerations are indeed different. Also, this is a native pest, and it's evolved with the trees and that we have in the southern U.S. And there are a whole host of common associates. Very, very, very cool from an ecological standpoint. The clarid beetle, the checkered beetle over here on the top left-hand corner of the screen, is one that's most commonly associated with southern pine beetle. There's a bunch of other predators like this hysterid beetle here in the middle. A bunch of different parasitoid wasps also help control populations to some extent. And there are a number of people in the South that have worked quite a bit with these parasitoid wasps. Brian Sullivan with the Southern Research Station is one of those people that knows quite a bit about biology of these insects. Also, there's phoretic mites. If you break a southern pine beetle out of a tree and you kind of look at it, you can see sometimes these mites on the exoskeleton of the southern pine beetle. And then depicted by my friend Kier Klepsik here is there's a whole bunch of different fungi associated with southern pine beetle, and I don't have time to go into all the different relationships between the fungi that SPB carry and what they do. But one of those fungi is important in the fact that it hastens the death of the tree. One of the associates, the clarid beetle or the checkered beetle that I showed, and the southern pine beetle are used in our spring trapping every spring. We try to predict what the population levels are going to be like for a given year. So in individual locations all across the southern United States, the state forestry agencies, national forest, forest health protection folks put out these Lindgren funnel traps over here on the right-hand side, baited with a host compound, alpha and beta pinene, and then a pheromone produced by the beetle, frontalin, and then we've started recently using endobrevicomum, also produced by southern pine beetle, as a means to collect southern pine beetle and the predator checkered beetles to determine if we have an increasing population, a decreasing population, is it going to be a high population, what have you. And I stole this slide from Brian Sullivan. But we do this all across the South, and we're trying to get better at predicting what outbreak would be like for a given year. One way that we're attempting to get better at this process is the Georgia Forestry Commission, most notably Michael Torbett and Chip Bates, put together this application, a Survey 123 application that when we go out and collect traps, we collect our beetles and we count the beetles, we can input into this app where the trap was. Over on the right-hand side, you put in the number of southern pine beetle collected and the number of clarids collected. And we do this over a period of 4 weeks in the springtime, starting with the dogwood bloom, I believe. It may be redbud now, but starting with the bloom of certain trees over a 4-week period, we do these collections. And this isn't available to everybody in real time, but to the other state forestry agencies and the National Forest and the Forest Service, we have access to this data, and you can kind of see what traps, where they are, what the beetle counts are as they are collected. And so this is only the second year of us doing it, and it's kind of a weird year with some people not being able to do field work, and um, people aren't able to go into their lab and do the collections and count the beetles. But the goal is here to be able to see what your neighboring state or your neighboring national forest, what they're collecting, and kind of get a better sense real time of what the situation is like out there on the landscape. And so this is data from this year, and I'm looking over here at this data from Louisiana and Texas, and again, I wouldn't expect any kind of impact there, but I'm starting to pay attention to what may be happening here in Georgia. And just as the traps come in, then you start to get a better idea of the situation. Also, with this data, we've been working with Dartmouth, Carissa Aoki and Matt Ayers and Steve Clark. They've developed a formula that you can input the number of SPB per day and the number of clarids per day and a number of other things. And kind of it pumps out a prediction formula for a given county. And this on the left-hand side is the western part of the southern US and then the eastern side of the US, where we had prediction last year of where we might have hot spots for the year. And then on the right is kind of what actually happened. Again, this is the first year trying this. We're tweaking it a little bit. We're getting a little bit better, and hopefully by late May, early June kind of time, we'll have pretty good estimates of where we should pay closer attention to, maybe do more aerial flights, maybe do more ground surveys, those kind of things based on trap catches. And generally, if we have a lot of trap catches in an area, we may do some aerial survey, or we have foresters driving around in those areas. You start to see on the landscape some dead or dying trees, and you may want to investigate those more. This is a spot that I talked about. On the right-hand side of the screen over here is where the spot originated. These are the oldest, deadest trees. And if this were a better picture, you'd see that the needles had probably fallen off, and this kind of skeleton trees left over where the spot started, and then the spots moved out this way. These are red and dead. Some of these are probably red but infested. And we call these the faders out here on the front, the red and yellow green. These are currently infested and dying trees. And then, of course, these green trees out in front, they're probably infested as well, but the needles haven't started to turn yellow yet. And that's important from a suppression standpoint. If you see these kind of spots on the landscape, you want to do some suppression activity earlier than later. And I'll talk more about what those suppression activities are here in a second. Also associated with aerial survey is if you do see spots like that, you do need to get on the ground and examine these trees up close to see what you're dealing with. Now that was clear evidence that it was likely a southern pine beetle spot, but you still need to get on the ground and check it. See these pitch tubes on the outside of the tree where the tree tried to pitch out the beetles, sometimes successfully, sometimes not. Ips beetles also have similar type pitch tubes, and black turpentine beetles as well, but as I mentioned earlier, it's important to know, are you dealing with southern pine beetle or are you dealing with Ips beetles, engraver beetles? If you peel back that dark, particularly like the trees that have been more had been infested longer ago, like the red infested trees, you can peel back the bark and see the southern pine beetle galleries, these serpentine galleries underneath the bark. Or if you had Ips, you might see a different pattern. So it's important to know what you're actually looking at. Is it the serpentine pattern, or these over here on the right, engraver beetles that actually engrave the sapwood of the tree? Southern pine beetle don't do that. And then this one on the right here is a black turpentine beetle, totally different, and wouldn't likely be confused with southern pine beetle, but may. But it's important to know what you're dealing with. I kind of want to switch gears here a little bit and talk more about this figure that I showed earlier, looking at data from 1960 through 2018. And you see this from 2004 through 2016, there really wasn't a lot of activity on a regional scale. There was some local activity that was important, but not multi-state, multi-year outbreak. And so the question is, why is that happening? And Chris Acero, myself, and Anthony Elledge put together just kind of a hypothesis paper as to why that might be. And you could probably have your own hypothesis as to why that is. But we looked at what seedlings we were actually putting out on the landscape over the same time period. And you see this red line here is the unimproved seedlings, and that started to decrease, whereas our improved seedlings that we're putting out on the landscape, the first generation improved, second generation improved seedlings are starting to become more prevalent on the landscape as you see these declines in southern pine beetle. So it's just one thing to think about. I'm not saying that there's a cause and effect relationship. I'm just saying that there is a coincidental change in what we're putting out on the landscape as far as the genetics of our seedlings versus population dynamics of southern pine beetle. Also in this paper, we looked at acres of fertilization, which is depicted in the green line, versus population dynamics. And we used fertilization kind of as a proxy or an indicator of the amount of forest management being done on the landscape. If you're fertilizing your stand, you're likely putting money into doing other types of things on the landscape. So we kind of use fertilization as kind of an indicator that more management was being done. And we think that you could make the argument, a reasonable argument, that the more good management, good forest management we do on the landscape, the less southern pine beetle that we're going to have to deal with. And so I think actually it may be a very good success story of good forest management leading to decrease in a forest pest on a regional scale. And so one of the reasons I wanted to talk about that was, even though we are seeing a decrease in multi-state, multi-year outbreaks on the landscape, when we do have outbreaks, it can be locally devastating. And from 2017 to 2019, particularly on the National Forest in Mississippi, the Bienville National Forest here in central Mississippi, and the Homachita National Forest, our ranger district in southwestern Mississippi, if you ask the people that work on those districts how important southern pine beetle is after the past few years, they will tell you it's very important. They got kind of ran ragged trying to catch up to the beetles, and really locally devastating. So the number of counties may be lower, but when you have an outbreak, if it's your 40 acres or your land or your national forest, it certainly can be locally important. More than 10,000 spots occurred in this time period, probably more than that, and thousands of acres were impacted. And it was particularly devastating because timber markets in some of these areas weren't very good, and it made suppressing the outbreaks or the spots more difficult. And with that, unfortunately, it made the spots bigger. So you could have gotten on those spots and stomped them out if you had a good timber market, instead of allowing them to grow and the populations to ramp up and those kind of things. And the red-cockaded woodpecker colonies on those national forests were impacted during this outbreak. So I talked somewhat about there are ways to control this insect. So if you have spots and you have 10 spots, that's the time to get out there and control them. You don't want to be dealing with thousands of spots at once because you just become overwhelmed. There's no way to get a handle on it when there's 1,000 spots. But if you have 10 or 20 or 50 spots, that's when to get after it. And there are two very effective means for controlling or suppressing an active spot, an active southern pine beetle spot. One is called cut and remove, and one is called cut and leave. And cut and remove is exactly what you would think it is. You go into a stand and you cut and remove the currently infested trees depicted here in the red trees, and then the green faders, green and yellow faders. And you also cut out, we recommend cutting out a buffer of green uninfested trees. So the beetles aren't in those trees yet, but they will be if you don't do something about it. And we recommend that buffer width to be about the average height of a tree. If your spots are growing really fast or you're having trouble getting back to those sites, you may consider making your buffer a little bit larger. And you want to get back there as soon as you can and remove those trees after you find a spot, particularly because, as I talked about, the beetles can go from the egg to the adult stage in 30 or 35 days. So if you wait 50 days, your buffer that you laid out, those beetles are going to be in there, and you're going to need to lay out a larger buffer than if you could have gotten back there in, say, 20 days before they were emerging and infesting new trees. If you don't do that, if you don't make your buffer large enough, you get what we call a breakout here. And you can see these trees were, the green buffer was removed here, and well, there must have been a couple beetles left over, and they got out here and started a new spot, or what we call a breakout. So it's important to get back and cut out all the infested trees and a good buffer. Advantages to this are you're removing the beetles from the site. You're getting some revenue maybe back from harvesting those trees. And really, I think what's most important is you're clearing that site for your next stand, your next forest. Your regeneration practices are going to be easier to do because you have a clean site. Disadvantages are it requires access, and you got to get the heavy forest harvest equipment out there. And most importantly, you need a buyer. Someone is going to need to want that wood. If markets are flooded with timber during an outbreak, or if the timber market is suppressed, you may have a lot of trouble getting a cut and remove operation accomplished. And that's unfortunate, but that's something that we've been dealing with more and more in the southern U.S., where nobody wants to come and do a cut and remove operation unless you're paying them to do so. But cut and remove, when done, is quite effective. Cut and leave is another means of suppression. It is effective, is not as effective as cut and remove. But if you can't get to a spot, or you can't get someone to buy your timber, this is a way to disrupt that pheromone biology and stop spot expansion. Advantages to this are, again, you can get to those sites pretty quickly, do the work, maybe even with chainsaw. They can be done quite quickly. Disadvantages are that no beetles are removed, so you need to go back and recheck those spots frequently. There's no revenue from the felled trees because you just left them on site, and it's not really suitable for large spots. So more than a half an acre, you really don't want to be doing cut and leave, or you're probably not going to be very effective. And then I think what may be the most important disadvantage of cut and leave is that regenerating that stand is going to be very difficult, because you just left hundreds of trees on the ground that you're going to have to deal with when it comes time to plant or regenerate that stand in whatever method. So you kind of left a mess out there when you do cut and leave, but sometimes it's the best option. So what are the if you do have an outbreak, what are the priorities? You want to get out there and treat the biggest, most active spots first. A high proportion of green, fading, infested trees, those are with room to run. You got one, that's kind of the spots that you need to get to. One that's maybe threatening other property, your neighbor's property, or in our case, the National Forest is threatening private land. You want to deal with those. Threatening red-cockaded woodpecker sites, those kind of things. Just things to consider when you're, if you can't treat all the spots, which ones you want to try to treat first. And if you do have southern pine beetle, or you suspect that you may have southern pine beetle, or you think you have southern pine beetle, or maybe hips, state forestry agencies are there to help. The county or district forester should be a first call. I sometimes get calls. People Google southern pine beetle, so I'll get a call, and that's perfectly fine. You know, I'm happy to answer those calls. The cooperative extension services, consulting foresters are all people that you can get in touch with if you think you have an issue with southern pine beetle. So at this point, I'm going to shift gears and kind of talk about what I've been working on for the past 17 years, which is called the Southern Pine Beetle Prevention Program. So we can manage southern pine beetle populations. We can manage outbreaks, but the goal is to try to not have the outbreak in the first place. And so this program got started in 2003 at the request of Congress after a huge outbreak that occurred in the southern Appalachian Mountains that impacted, like I said, about 1 million acres and cost about $1 billion worth of damage and huge ecological impact as well. And we worked with 12 national forests in 13 southern states over the past 17 years. We don't work with every national forest every year, and we don't work with all 13 states every year, but we have worked with them over the past 17 years to various degrees. And the basic tenets of this program are just to increase forest resiliency through good forest management, forestry 101 type stuff. Then when you're supposed to use prescribed fire and put the right tree species on the right site, restoring native longleaf where it's appropriate, put shortleaf pine back where it's appropriate, those kind of things. Through this program, mostly through the State Forestry Agency cost share programs, we've treated about 1.3 million acres and have directly impacted more than 16,000 landowners and loggers through those state cost share programs. And again, the basic premise of the program, not rocket science, is just put the right tree species on the right site. So top left-hand corner up here is a shortleaf pine stand in Arkansas. Down on the right-hand side is longleaf pine in northern Florida. Low intensity fire, frequent fire is part of the forest management equation, and preferred stand density. We recommend when you do your thinning to thin down to 80 square feet of basal area after the thin, and don't let that get too much over 120 square feet of basal area before you consider doing your next thin. You want to have, the reason behind this is you want to have good healthy diameter growth, a good live crown ratio greater than 33%, and adequate tree spacing. And I'll talk about why tree spacing is important here in a minute. So kind of want to, after you're thin, you may consider that 20-foot mark. And I'll talk more about why I think that's important here in a second. In addition to reducing your susceptibility to southern pine beetle, all these treatments have great other benefits, including increased economic return, reduced fire risk, improved wildlife habitat. I love seeing the National Wild Turkey Federation presentations, the Quail Unlimited presentations. You know, it's kind of the same type of forest stand structure that they're shooting for as what I would say we're shooting for, although their basal area may be a little bit lower than ours. And I think those stands just look better than a dog hair thick loblolly pine stand. You know, it's certainly more it's a better day out in the woods when you're walking around in that park-like condition than a thick with all kinds of understory growth. And if you want to know more about this program, as Molly mentioned, we did put together a story map a few years ago, and I think Molly did provide a link to this. And you can see where all the treatments have occurred on the landscape over the past 17 years. This is updated through 2016. We're working on adding the 2017 and 2019 data, but you can click on each one of those dots and see the type of treatment that happened and how many acres and all that stuff. And also there's contacts in there if you live in Mississippi and you want to be part of this program, or if you live in Florida and you want to see what you're doing in your state, you can do that. Most of our treatments, this is a pie chart with all those dots kind of added up. And on the left-hand side over here, you see that most of the work that we've done is either first thinning or pre-commercial thinning, done some prescribed fire under this program, and then some restoration work, either low density pine planting or long leaf or short leaf restoration type stuff. So the question is, are we certain that thinning prevents southern pine beetle? And really, I'm sure everyone on here would agree with me. There's been a lot of data, a lot of work done on this particular question, and the answer is a resounding yes. During the early 1980s, Evan Nebeker, John Hodges did a bunch of work where they artificially infested some stands and then watched the spot growth or the number of trees that were killed. And as you got above 80 square feet of basal area, the number of trees that were impacted increased as basal area increased. We also had this opportunity to evaluate our prevention treatments on the landscape in 2013 on the Bienville and the Homachitted Ranger districts and on the National Forest of Mississippi. And basically what we found was where they had thinned their loblolly pine stands in the past 5 to 6 years, they didn't have any southern pine beetle spots. There were only 2 spots out of more than 900 that occurred in those thinned stands. So where they had done their thinning recently, they just really didn't have an issue with the beetle. So why does thinning prevent southern pine beetle? In forestry class, I know I learned that the healthier trees produce more resin and they're more likely to pitch out those beetles. I think that's definitely true. There's been a whole host of work on that down here on the bottom that talk about resin flow and the ability of individual trees to protect themselves from southern pine beetle. I also want to talk about stand structure like you see over here on the right-hand side of the screen. I think, and I'll make my argument here in a minute, that stand structure is just as important as individual tree health in protecting a stand from southern pine beetle. I think if you look at this stand, it's very open, wind flow is going to be high, a lot of sunlight hitting the ground. And I think that's important from a pheromone standpoint, and I'm going to talk about that more in a second. But the reason I think this is important is if you thin this stand on Tuesday, the stand structure is different on Wednesday. And I think that has an immediate benefit if you have southern pine beetle in an area, whereas the change in resin flow is certainly not going to change overnight because it's going to take time for the trees to add canopy and the roots to grow and resin flow to be increased, maybe 3-4 months for that all to happen. But stand structure changes as soon as it's done. And the reason I bring this up, there's a couple things. There were some studies done by Guerra and Koster back in the 60s and 70s that showed that as you increased the distance between trees from an infested tree outward to adjacent trees, as you increase that distance, the beetles are less likely to jump to those trees. So if you go from 5 feet between the trees to 25 feet, somewhere in here, the beetles stop going to the adjacent trees. And we think that's about 20 feet. They repeated this in a more natural situation during an SBB outbreak. And the probability of adjacent trees being attacked in their study decreased the distance from the attacked tree. So as they got out here to about 5 meters or 6 meters, about 20 feet, they saw the probability of adjacent trees drop dramatically. So I think that's important, not only from like, do you thin during an outbreak? Does it change immediately for that stand? And I think it does. But also, what type of thinning are you doing? In the South, we do a lot of this row thinning, which can be quite effective. It's cheaper to do. You know, get your heavy equipment down those rows and pick off some adjacent trees, like here on the left-hand side. But we also do thinning by spacing. And I think from a southern pine beetle, this thinning by spacing makes more biological sense. And this stand on the right is more protected from SPB than the stand on the left. I've seen where beetles will march down the line of residual trees, or let's say this was a road. I've seen where the beetles march down the road, but they don't cross the road for whatever reason, and they just stick to one side of the road or the other, or one side of a row. So just consider that when you're doing a thin. Maybe thinning by spacing is something that you would consider. And I think this has a lot to do with the pheromone communication. Harold Thistle and Brian Strom did a study back in 2004 and 2005 where they looked at how a pheromone would act in a stand under certain basal areas. Basically, what they found was that as you thin a stand, there's more solar radiation hitting the forest floor, and also there's a lot more wind movement in those stands. And so I think that what happens there is as you thin the stand and it becomes more open, the pheromone plume is more likely to blow out of those stands, and it's more difficult for the beetles to try to find where the next tree is or where the source of the next pheromone is. And so I think that's why spot growth in those thin stands is less impactful than in stands that are unthinned. So basically, our thinning recommendations are thinning will absolutely prevent southern pine beetle in most cases, not all, but in most cases. Consider thinning by spacing and that 20 feet distance between individual trees after the thin, if it's appropriate from a basal area standpoint and a forest management standpoint. And then try to create an open understory, either with a herbicide application or with a low intensity frequent fire regime in your stand. So I've talked somewhat about prescribed fire, and does prescribed fire, is that part of an SPB prevention tactic? I say the answer is yes, and certainly it's been something that we've encouraged to the prevention program. There is less great data associated with prescribed fire in southern pine beetle than with thinning. But I argue that low intensity fire is part of these forest ecosystems. It helps change that stand structure, reduces understory competition. We did see some in the 2013 study that I talked about that was published in the Journal of Forestry in 2015. We not only did we look at thinning, but we also looked at prescribed fire. And what we saw, at least in one case, was that there were less spots associated with southern pine beetle or with stands that had been burned in the past. That was on the Homachita Ranger District. On the Bienville Ranger District, we didn't see any differences. And so there's been other studies and more recent work where we've had some conflicting views. We get one answer one time, we get the opposite answer another time. And so there's more to be answered here. We are currently working with Louisiana State University and Louisiana Tech in Louisiana on kind of a more in-depth evaluation of these treatments, and we hope to get to the bottom of it in the next few years. But there's not a ton of data out there associating fire and bark beetles in the South, and so we're trying to get a better understanding of what's going on there. But I think if you look at these two stands, the one on the left, I think is going to be lower hazard than the one on the right. I think the pheromone plume with that amount of understory is way more likely to sit in this stand over here on the right than the one on the left. You're going to have a lot more wind in the left, a lot more sun hitting the ground than the one on the right-hand side. And so kind of my concluding slide there is then when you can, when it's appropriate from a forest management standpoint, and also consider low intensity fire as part of your forest management, not only from a southern pine beetle perspective, but from other perspectives as well. And with that, Molly, that's all I got for today.
All right. That was such an excellent presentation, Dr. Nowak. Thank you so much. I know a lot of us have been waiting for this one for a long time. And yes, I just wanted to thank you for taking time out of this crazy period, undoubtedly a huge list of Zoom meetings to present for us. And thank you to the audience. We have so many attendees today, guys. This is, at least as for my eyes, record breaking. So thank you all for taking time as well. Dr. Nowak, because we have such a huge audience here, we do have a long list of questions. Folks, I will do my best to answer all of them, to ask all of them. But if you still have a nagging question that we didn't address, please feel free to send it to me either through my email or the chat box, and I can take it up with Dr. Nowak separately. All right. Yes, I know we would be hearing a resounding applause if we could. So that was so great, Dr. Nowak. Thank you.
Thank you.
All right, sir. Let's get started here. Okay. Carlos Fletchman from Brazil says hi, and he would like to know if you think that SPB could move further north as we see it happening with the mountain pine beetle.
Hello back to Carlos. I'm glad he's with us from Brazil. Also, I think that there is an opportunity for it to move north. Like I said, it's on Long Island. That's not on our range map. It's been there for a decade. It was been wreaking havoc in New Jersey, which we kind of consider to be the northern tier of southern pine beetle. And it has been trapped recently in Connecticut and Massachusetts. But the question remains, like, how much were we really trapping for southern pine beetle in Massachusetts 15, 20, 30 years ago? I don't know the answer to that. I also think host type may be somewhat quite a bit different as it moves north there, but there are people. I think Kevin Dodds, Matt Ayers wrote a paper about range expansion. That certainly is worth a read, and there may be a possibility for it to move north with differences in climate over time.
Excellent. A couple folks would like to know, just in your personal opinion, do you have any ideas why populations have been under control in recent years or in the 2000s?
I do think that forest management has played quite a bit of a role there. I really do. I think we're very good in the South on a whole of doing a good job of forest management. Um, I think there could also be a change in climate that could be impacting population dynamics. I considered throwing in a slide about that, but I don't actually have any data. It's just kind of a thought in my mind that with warmer winter temperatures, it could be disrupting a peak emergence in the springtime that could be altering their ability to kind of coalesce in one shortened period of time versus they just kind of emerge throughout the winter and never really get an opportunity to kind of coalesce into a meaningful population.
Excellent. Yeah, we had a couple people follow up with wondering if climate change had any effects, but yes, it definitely sounds that being on top of forest management is one of the primary reasons. Okay. Oh, this is a really specific question, but on the Common Associates page, someone wanted to know if they are all native.
I'm fairly certain that all of those that I showed are native species, yes. And I wish I could have showed them all and talked quite a bit about them. That's a whole different presentation. There's hundreds of associates, all of which I believe to be native.
Okay. Someone would like to know where they can find more information about the fungi associated with southern pine beetle.
Well, you can always look to a book called Southern Pine Beetle 2. And if you want a copy of that, I'd be happy to ship you one, or if you give me your contact info through Molly, or just email me directly. There's a whole chapter, I believe, on fungi. Kier Klepsig has written several papers on those fungi as well.
Excellent. And I was just texting with Kier, and he wanted to let people know that he is also available if you want to send him any fungi related questions.
Cool. Very good.
Yeah. Sorry. Oh yes, the map with the active southern pine beetle trap data, is that available to the public?
The early parts of the map, as we're doing the trapping collections, I don't believe are available. We didn't want to give people, you know, missing information or false information right out of the gate, like, incomplete information. Not that it's false, but just incomplete information before we got the full picture. And so we're hoping to have the map and the prediction available to everybody by the end of May, early June, kind of thing. As I mentioned, it's only the second year of us doing it, and this year is kind of all over the map, with people being able to do the collections, people being able to count their collections, and those kind of things. But the map's not currently available to everyone, but I believe it will be, I think, by the end of May or
Gotcha.
early June.
Makes sense. Oh, so this is a nice, simple question. We've definitely covered it, but I think it would be good to go over. What makes beetle-killed pine wood turn blue?
It is the fungus. The fungus gets in there and goes through the sapwood and creates that blue staining. And that's not only for southern yellow pine, but also for western pine trees as well, that get attacked by western pine beetle and mountain pine beetle.
Okay.
And so it's kind of a cool look. But some people, the mills often won't take that blue stained wood.
Right, right. Okay. Sorry, just a minute. Sorry, folks, there's just some repeats here I'm working through. Oh, yes. In the cut and remove method, wouldn't transporting the wood contribute to the spread of SPB?
The answer to that is we don't 100% know. But Brian Sullivan was actually asked that question at a state line meeting that we had a number of years ago, and I think he was going to try to explore that. That's kind of a tough question to get to, but let's say the mill is in the same county that you're experiencing the outbreak in, and there's beetles. There are beetles everywhere, for sure. We don't think that a truck driving down the road is going to produce enough beetles to really cause that much impact. I remember thinking at the time that the question was posed, if I were an adjacent state with no outbreak, I don't know that I'd want a bunch of trucks rolling over the bridge to my state if I didn't already have southern pine beetle. But the answer basically is we don't know, and a difficult question to kind of try to answer. So
For sure, for sure. Sort of on the other side of that, are there any situations in which one would want to maintain an infested area to support red-cockaded woodpecker populations?
I would definitely say no. Woodpeckers can get into those infested trees. I don't know that red-cockaded woodpecker do, but woodpeckers do benefit from all the common associates associated with them. But in the fall time, southern pine beetle go through this kind of fall dispersal. And what they do is they'll selectively pick out those RCW trees. And so National Forest of Mississippi with the huge populations that they had, lost several colony trees when those beetles moved out to kind of find their overwintering site. So it's not something I would want around my RCW trees at all. It can impact the foraging area, the colony trees, those kind of things.
Fair enough. Okay, when a spot occurs, how can you predict what direction it might grow and expand, if you can? Is the direction based on prevailing winds pushing the flight of the insect?
I don't know about the wind part, but certainly, let's say you have generally, if you find a spot, you can go out there and kind of see which direction it's moved. And for whatever reason, it does tend to go in one or two different directions. Sometimes you'll have multiple spot heads, but if you find a spot, you can see regression from the totally dead skeleton trees to the red dead to the red infested to the yellow and green faders. You can kind of see where the spot is moving. And I think there's a number of reasons why it would move in a certain direction.
Cool. Yeah.
Considering even where the host is, sometimes it'll move, like I said, move away from the road or won't go into a hardwood stand or whatever.
Right, that makes sense. Okay, is an RNAi pesticide being developed for SPB like it is for mountain pine beetle?
Don't know the side part of it, but I know that a graduate student, I think her name is Beth Spire. I'm sorry, I can't remember her last name, but she works with Lynn Risky-Kinney, was looking at some RNA activity, and she gave a great presentation on the impacts of that stuff at I believe at last year's Southern Forest Insect Work Conference. So Beth Kyer, I think is her name.
Okay.
I'm not sure if she's published on that or not, but and I don't know how far along they are with that, but yes.
Excellent. Excellent. We can look into that. Um, okay. Does creating tree farm monocultures with all the trees the same age contribute to their susceptibility of SPB damage?
Well, I think that's something that people think, but that was kind of why I was trying to show that data about change in forest management over time. And Steve Clark and Fred Steven and Ron and John Riggins also kind of looked at forest management and southern pine beetle populations over time. And so I think there's a real strong argument that good forest management, not just no forest management, has led to reductions in southern pine beetle. So certainly, no question about it, a 25-year-old unthinned loblolly pine stand is the worst condition that you can have um, for southern pine beetle. Those are the most susceptible stands by far. You do want to have a mosaic of stand structures and stand conditions, mixed hardwood pine stands out on the landscape. But a well-managed pine plantation doesn't have to be beetle bait as long as you thin when you're supposed to and pay attention to your situation.
Okay, excellent. I think we only have time for one or two more. This one is again relating to a specific figure. Going back to the graph showing outbreaks over time, could you just remind us what the red dotted line represents? And let me know if you don't know which graph I'm referring to.
You know, I was going to ask the person that put the red dotted line on there what that represented, but
Yeah.
I think that that was kind of the average over time of, like, let's say 50 counties or a little over 50 counties. That was kind of the average outbreak history over the life of that 60 years.
Okay. Okay. Okay, just one more here. Do individual insects survive an entire season and continue to infest multiple trees? Infested tree lay eggs and then move on to the new tree, or is it only the next generation that continue the infestation?
The adults can go into trees, lay eggs, produce larvae, larvae and then move to the next tree. So they are a part of the expansion of the spots for sure. So they can infest multiple trees.
Okay. All right. Perfect. Folks, I'm really sorry. There are so many other really great questions here that I didn't get to, but I will put them all together and we will try and figure out something where we can offer more supplemental information. Thank you again all to attended. Thank you so much to Dr. Nowak. This was such a treat to listen to and be a part of. Um, Dr. Nowak, if you can feel free to sign off. We have definitely kept you here long enough. And folks, if you have specific connectivity issues, CEU questions, stuff like that, really anything at all, I'm going to be hanging out here for another 20 or 30 minutes. So feel free to hit me up in the chat box. All right. Thank you so much, Dr. Nowak. I'll be in touch.
All right, great. Thank you.
All right, take it easy.